Hello everyone, welcome to my YouTube channel School of Chemistry. So today we are going to study about isomerism. So what do you understand by this term isomerism? Actually it arises from the word isomers. Now what are isomers? Isomers are the compounds having same molecular formula but different structures. And this phenomenon is known as isomerism. This phenomenon is known as isomerism. Okay, now what are the different type of isomerism that exist? So we have to study two types of isomerism. Majorly it is of two types. That is, first one is the structural isomerism. Structural isomerism. And second one is the stereoisomerism. So today we are going to study about structural isomerism. So structural isomerism is further divided into six types. First is the chain isomerism. Second, positional isomerism. Third is the functional isomerism. Fourth is the metamerism. Fifth one is tautomerism. And sixth one is the ring chain isomerism. If we talk about stereoisomerism, then it is also further divided into two types. Majorly which we have to study is geometrical and optical isomerism. Geometrical and second one is optical. Which we have to study in class 11th. Okay. Now let us first start with the structural isomerism. Now what that is the first part, which is chain isomerism. So those compounds which have the same molecular formula but different number of carbon atoms in the parent chain are said to be structural isomers, or you can say chain isomers. Said to be chain isomers. Let me make it more clear by taking an example. Let us write C5H12. So we can make the isomers of this molecule C5H12 as CH3, CH2, 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 and we have CH3. Okay, this we can write as N-pentane. Then we have CH3, CH, CH3, CH2 and CH3. This we can write it as isopentane. And the third isomer or the third chain isomer which we can draw for this molecule is CH3, CH3, over here CH3, and we can write down its name as neopentane. So over here I've used the common names, and we can even write down the IUPAC names of these compound. Like simply we can write pentane, 2-methylbutane, 2,2 dimethylpropane. Okay, and these all are the chain isomers of this compound C5H12, which we normally call as pentane. Okay, fine. So let us move to the next isomerism, second, which is our positional isomerism. In positional isomerism, again we will have the same molecular formula of the compound, but different position of substituent. It may be multiple bond or functional groups. Let me explain this by taking few examples. Let us take an example. First, take out the example of the this substituent, that is CH3, CH, CH3. This we can write as 2-methyl pentane, and it will be an isomer with this compound CH3, CH2, CH. We can write CH3 on the third carbon, then CH2 and CH3. This is 3-methyl pentane. Okay, so 2-methyl pentane and 3-methyl pentanes are positional isomers, as we have different position of the methyl group in this molecule. If we take the example of multiple bond, then we can write CH2 double bond CH, single bond CH2, and then CH3. We can write butene or but1-ene. That will be an isomer with CH3, CH, double bond CH, then CH3. This will be but2-ene. So these are, you can say, positional isomers in which the position of the multiple bond is different. One of the molecule having a position at the first carbon atom, and the second molecule is having the position of the multiple bond starting from the second carbon atom. Let us take an example with the functional group. So for that, we can write as CH3, CH2, CH2, OH. This one is propanol, and we can draw its isomer as CH3, CH, OH, CH3. This will be propane 2-ol. Okay, so these are two are positional isomers in which the position of the functional group is different. In propanol, the position of the functional group or the OH is on the first carbon atom, whereas it's there on the second carbon atom in the next of the isomer. So these are positional isomers. Third, structural isomerism is the functional isomerism. In this functional isomerism, compound again having the same molecular formula but different functional group present in them. As the organic compounds are determined by the type of functional group present on them. So that's why if the functional group present of any molecule changes, then whole of the properties of that compound changes. So let me explain you about this functional isomerism with an example, that is C2H6O. So we can write down this molecule as CH3CH2OH. Okay, and this is, it's an alcohol, so we can name it as ethanol. Whereas if I can write it as CH3OCH3, it becomes an ether, and we can name it as methoxy methane. Okay, so first of the molecule is having an alcohol as a functional group, second molecule having an ether as a functional group. Let me take one more example of an aldehyde having functional group with ketone. So this is an propanol, okay, and it would be an isomer with CH3 C double bond O CH3. This is propanol. So these two are functional isomers. Fine. Okay, one more example that is coming in my mind is CH3 CH2 COOH. We can write down it as propanoic acid. Fine. And the functional isomer along with this molecule CH3 C double bond O, and then we can write one more CH3. This is methyl ethanoate. Okay, so these two are again functional isomer, one of the molecule having acid as a functional group and the other one having an ester as a functional group. So these are functional isomers, that is compound having same molecular formula but different functional groups present in them. Next type of structural isomerism is the metamerism. Okay, so metamerism arises in molecule, or we can say compounds, in which the functional group lies in between the chain. Okay, so it arises in the compounds having functional group in between the chain where we have different number of carbon atoms on either side of the functional group. So this is shown by the compounds like ether having the you can say carbons on both the sides. It can be shown by ketones, it can be shown by secondary amines having NH, it can be shown by even esters having the alkyl group on both the sides. So let me further explain you with an example. Okay, let us take an example of first an ether, after that I will take an example of ketone. So CH3 CH2 O CH2 CH3. In this molecule we can see that on both sides of the oxygen atom we have two carbon atoms, and we can name it as ethoxy ethane. and the metamer of this molecule which we can draw is CH2, CH2, and then VCH3. So this could be written as methoxy propane. So these two are metamers. Okay, and the isomerism shown by them is a metamerism. Another example we can take over here is CH3, CH2, C double bond O. This is pentane 3O. Okay, and the isomer to this molecule can be drawn like this, which we can write it as pentane 2 on. So again, these two are metamers. Okay, so next comes the tautomerism. Now it is a special type of isomerism. Type of isomerism which arises due to migration of a hydrogen atom from one polyvalent atom to another within the same molecule. Within the same molecule. And the isomers exist in dynamic equilibrium with each other. Okay, let us take an example. The best example to explain this tautomerism is the keto-enol tautomerism. Further, if we study this tautomerism, it is classified into two types, that is triad system and the diad system. That depends on the migration of this hydrogen atom, whether that migrates from the first or between two atoms or between three atoms. If it migrates between two atoms, we call it as a diad system, and if it migrates between the three atoms, we call it as a triad system. So let me take an example of the triad system, which is the keto-enol tautomerism. Keto-enol tautomerism, and I will explain you how this operates. So let us take the enol form, CH2 double bond C OH, and then we have the CH3. So this one is the enol form. Now we have the two lone pairs on the oxygen atom. So what happens actually, the carbon oxygen multiple bond is much stronger as compared to the carbon carbon multiple bond. So the electron migrates over here to form bond between this oxygen and the carbon, and the multiple bond between these carbon atoms breaks down and the electron gets shifted to this carbon atom. Fine, so we have CH2 negative single bond carbon, and a double bond is formed between this oxygen. So as a result, one positive charge appears over here, hydrogen, and we have CH3. Now oxygen is an electronegative atom. Okay, and presence of this positive charge on the oxygen makes it highly unstable. So what happens, the bond between this oxygen and hydrogen breaks down and the electron gets shifted to this oxygen, and the hydrogen is removed as H positive. Okay, so we can represent it as CH2 negative, single bond, double bond, oxygen. We have two lone pairs and CH3. Now this H plus would be present in the test tube only. Okay. Now the lone pair of electrons which are present on the CH2 is going to attack on this hydrogen and gains this hydrogen and leads to the formation of the neutral molecule, that is CH3C double bond O CH3, which is the keto form. So this enol form gets converted into this keto form by the transfer of or the migration of this hydrogen atom from this 1, 2 and this third atom. So it is also known as 1,3 migration or the triad system. Let me give an example of the diad system and also, that is HC triple bond N. Okay, hydrogen cyanide, hydrogen cyanide. It can also be represented as C triple bond N then H. So we can represent lone pair over. It is hydrogen isocyanide. Hydrogen isocyanide. Okay, and this is formed due to the migration of hydrogen atom from carbon to nitrogen. That is from atom 1 to atom 2. Okay, that's why it is also known as 1,2 migration. Okay, or 1,2 shift, and studied under the diad system. So this was about the tautomerism. Next type of isomerism, that the sixth type is the ring chain isomerism. So this type of isomerism is shown by compounds which exist in open chain structure, with multiple bonds and as cyclic ring bonds. Let us take an example. For example, if we have CH2 double bond CH3, now this molecule can be also represented as cyclopropane. It means we will be having CH2 at all the corners. Okay, means will be having 3 carbon atom and 6 hydrogens. Let me take one more example. If I have CH2 double bond CH2 CH3, then this could be represented as cyclobutane. Okay, and it can also be represented as CH3. Okay, with cyclopropyl methane, cyclopropyl methane. So these are the ring chain isomerism. Okay, in the open chain structure, the molecule will have a multiple bond, and in the cyclic form, that will be represented as an alkane. If it would be having more than one multiple bond, let us take an example of this CH2 double bond CH, single bond CH, then we have double bond CH2. This could be also represented as one multiple bond, and it could also be represented as CH3. Fine. So these are the ring chain isomers of this molecule. Fine. So it finishes off with the structural isomerism. Hope my videos are helping you in your studies. So for more such interesting videos, please like and subscribe to my YouTube channel School of Chemistry. And in the next incoming video, we will be discussing about stereoisomerism, that is about the geometrical and optical isomerism. Thank you.